Hello everyone and welcome. Today we are diving into the modern world of ultrasonic sensor. These remarkable devices are at the forefront of modern technology, playing a crucial role in variable industries. But what exactly is an ultrasonic sensor? Simply put, it's a device that uses sound wave at frequency higher than the audible range to measure distance, detect objects, and even map environment. The significance of ultrasonic sensors cannot be overstated. They are widely used in automotive systems for parking assistance and collision avoidance, in industrial automotive for object detection and position sensing, and even in healthcare for medical imaging. Stay tuned as we explore how ultrasonic sensors work, their application, and the future advancement in the exciting field. Let's get started.
Welcome back! In this segment, we will dive into the scientific instrumentation and applications of ultrasonic sensors. First, let's define what an ultrasonic sensor is. An ultrasonic sensor is a device that emits ultrasonic sound wave and measures the time it takes for the echo to return. This information is then used to calculate the distance to an object or surface. Now, let's see how ultrasonic sensors fit into the field of scientific instrumentation. Ultrasonic sensors are pivotal in various scientific research and industrial applications due to their precision and reliability. They are commonly used in non-destructive testing to detect flaws in materials, in level measurement systems to monitor the height of liquids in tanks, and in environmental monitoring to map underwater terrains. To understand their operation, we need to grasp a few key concepts, which include frequency, wave propagation, and echo detection. The first one is frequency, which refers to the number of sound wave cycles per second that is measured in hertz. Ultrasonic sensors operate at frequency typically above 20 kHz, which is above the range of human hearing. Next, wave propagation is the movement of sound waves through a medium such as air or water. Ultrasonic sensors emit waves that travel until they encounter an object. Lastly, echo detection. It involves capturing the reflected sound waves, which is echoes, that bounce back from the object. By measuring the time delay between the emission and reception of the echo, the distance to the object can be accurately calculated. It is important to understand this concept to appreciate how ultrasonic sensors provide accurate and reliable measurements in scientific and industrial contexts.
In this segment, we will conduct a detailed exploration of ultrasonic sensor, diving into their working principle, type, and comparison with other distance measurement technologies. The working principle of ultrasonic sensor involves three main components, which is a transmitter, a receiver, and signal processing circuitry. For transmitter, this component emits ultrasonic sound wave, typically using a piezoelectric transducer. For receiver, the same or a separate transducer detects the sound wave reflected back from an object. For the last one is signal processing circuitry. It measures the time interval between transmission and reception, then calculate the distance using the speed of sound. Let's explore type of ultrasonic sensor. We have proximity sensor detect the presence or absence of an object within specific range. They are commonly used in applications such as automatic doors, collision avoidance system, and robotic arms. Second, we have distance measuring sensor. Accurately measure the distance between the sensor and an object. These sensors are used in industrial automation for measuring leveling tons, distance or conveyor system, and vehicle parking assistance system. Third, we have flow sensors. Flow sensors measure the flow rate of liquid or gases. They are applied in water and gas meter, medical devices for monitoring blood flow, and industrial flow monitoring system. Plus, we have level sensor. Level sensor measure the level of liquid or solid in a container, commonly used in water treatment plants and chemical storage tanks. This sensor ensure accurate measurement of material level to avoid overflow or shortages.
Okay, now let's compare ultrasonic sensor with other measurement technologies. There are several measurement technologies that we can compare its weaknesses and strength with ultrasonic sensor. First, we have infrared sensor. Infrared sensor use infrared light to measure distance. They are generally less expensive and less accurate over longer distance compared to ultrasonic sensor. Next, we have laser rangefinder. Laser rangefinder use laser beam to measure distance. They offer high precision and long-range capabilities, but can be more expensive and sensitive to dust and fog. Next, we have radar sensor. Using radio wave, radar sensor can measure over a long-range distance and through various material. Radar sensors are highly accurate but more costly and complex compared to ultrasonic sensors. Okay, welcome back. In this segment, we will focus on a specific and fascinating application of ultrasonic sensor, distance measurement in robotics. Robotics is an ever-evolving field, and the ability of robots to perceive their surroundings accurately is crucial for their functionality and safety. This is where ultrasonic sensors come into play, providing reliable and precise distance measurement. Now, let's delve into how ultrasonic sensors are used in robotics. Okay, first, obstacle detection and avoidance. Ultrasonic sensors are often mounted on mobile robots to detect obstacles in their path. By continuously emitting ultrasonic waves and measuring the time it takes for the echoes to return, a robot can determine the distance to nearby objects. This information is processed in real time, allowing the robot to navigate around obstacles and avoid collision effectively. Then, autonomous navigation. For robots to move autonomously, they need to understand their environment. Ultrasonic sensor can help create a map of their surrounding by measuring distance to various objects and surfaces. This data is used to build spatial representation, enabling the robot to follow a path to its destination without human intervention. Next, proximity sensing. In tasks that require precision, such as picking and placing objects, robots use ultrasonic sensor to measure the distance to the target object accurately. This ensures that the robot's movements are precise, reducing errors and enhancing efficiency. Next, indoor localization. In indoor environment where GPS signal may not be available or reliable, ultrasonic sensor can assist in localizing the robot. By strategically placing multiple sensors around the robot, it can triangulate its position within a defined space, ensuring accurate movement and positioning. Okay, to illustrate, consider a robotic vacuum cleaner. You guys can watch this video. Equipped with ultrasonic sensors, it can navigate around furniture and other obstacles while efficiently cleaning the floor. The sensor helps the robot maintain an optimal distance from walls and objects, preventing collision and ensuring true cleaning. Okay.
Real-world implementation of ultrasonic sensors across various industries showcasing how these versatile devices are making a significant impact. First, we have healthcare industry. In healthcare, ultrasonic sensors play a crucial role in medical imaging, particularly in ultrasound machines. These machines use high-frequency sound waves to create image of the inside of the body, helping doctors diagnose and monitor various medical conditions. Ultrasonic sensors are also used in therapeutic applications, such as physiotherapy devices that deliver targeted sound waves to treat musculoskeletal conditions. So, case study of healthcare industry shows that portable ultrasound devices equipped with advanced ultrasonic sensors are revolutionizing healthcare in remote and underserved areas. This compact device allows healthcare providers to perform diagnostic imaging at the patient bedside, improving access to medical care and reducing the need for expensive hospital visits. Next, we have automotive industry. In automotive industry, ultrasonic sensors are integral to modern vehicles, enhancing safety and convenience. They are commonly used in parking assistance systems, helping drivers maneuver their vehicles into tight spaces by providing distance measurements to obstacles. Additionally, ultrasonic sensors are used in collision avoidance systems, alerting drivers to potential hazards in their blind spot. So, case study of automotive industry is Tesla autopilot system use an array of ultrasonic sensors to provide 360-degree visibility around the car. These sensors detect objects and measure distance, enable features like automatic parking and lane keeping. The integration of ultrasonic sensor with other sensing technologies ensure a high level of safety and automation.
These are a few ultrasonic sensor advantages that have clarified what application our sensors are suited for. First, it's not affected by color or transparency of object. Ultrasonic sensor reflects sun off of object, so color or transparency has no effect on the sensor's reading. It also can be used in dark environment. Unlike proximity sensor using light or camera, dark environment has no effect on an ultrasonic sensor detection ability. Next is also low-cost option. Our sensors start at $29.99. They come fully calibrated and ready to use. We strive to give a low-cost, high-quality product suited for specific needs. Other advantages of this ultrasonic, it does not get affected due to dust, dirt or high moisture climate. The sensors are working effectively in all kinds of environment. It provides the right kind of reading needed to tackle the situation. The ultrasonic water level sensor is having no moving part and thus has longer life as compared to contacting alternative. These sensors are highly accurate and help in the quick detection of small alternates in the position. It assists in the measurement of object thickness and the depth of parallel surface. Select the best quality ultrasonic sensor that fit effectively in the Purity product and thus can be used safely in the installation. Although we fully believe in the capability of our sensor, we understand that ultrasonic are not suited for every application. Below we go into the limitation of our sensor. Ultrasonic cannot work in a vacuum because ultrasonic sensors operate using sound. They are completely non-functional in a vacuum as there is no air for the sound to travel through. Then, ultrasonic not designed for underwater use. This is because our sensors have not been properly tested in this environment, so underwater use why our warranty. This being said, we do supply documentation for customers who would still like to test our sensor underwater. Ultrasonic also have a limited detection range. At the moment, our standard longest ranging sensor have a maximum range of 10 meters. Now, our cargo sensor detects up to 16.5 meters. Why this is disadvantage in certain applications? Our sensors have a great mid-range capabilities and are still suited for many applications.
First, let's explore some current research trend in the field. First, miniaturization. One of the key trends is the miniaturization of ultrasonic sensor. Researchers are working on developing smaller and more compact sensors without compromising performance. This miniaturized sensor can be integrated into a wider range of devices. including wearable technology, medical implant, and compact robotics. Second, integration with AI and machine learning. Other significant trend is the integration of ultrasonic sensor with artificial intelligence AI and machine learning ML. By combining sensor data with advanced algorithms, we can enhance the capabilities of ultrasonic sensor. For example, AI can help in more accurately interpreting complex echo pattern, improving object recognition, and enabling predictive maintenance in industrial application. Okay, now let's look at some potential future innovation. First, enhanced range. Future development aim to extend the detection range of ultrasonic sensor. This can be achieved through advancement in material and transducer design, as well as improvement in signal processing technique. Enhanced range would make ultrasonic sensors suitable for a broader array of applications, including those requiring long-distance measurement. Second, improved resolution. Researchers are also focused on improving the resolution of ultrasonic sensor. Higher resolution of be achieved by increasing the frequency of ultrasonic wave and the signal processing algorithm. This would enable more detailed and accurate measurement, which is particularly important in applications such as medical imaging and precision manufacturing. Third, multimodal sensing. The future may see the development of multimodal sensors that combine ultrasonic sensing with other types of sensors, such as optical or radar sensor. This combination can provide a more comprehensive understanding of the environment by leveraging the strength of different sensing modalities and energy efficient. Improving the energy efficiency of ultrasonic sensor is another area of focus. More efficient sensor would be benefit for battery power application such as portable medical device and autonomous drone by extending their operation life. Lastly, smart material and transducer. Advances in material science may lead to the creation of smart material and transducer that can dynamically adjust their properties to optimize performance under varying conditions. This innovation could make ultrasonic sensors more adaptable and robust in challenging environments.
To summarize, ultrasonic sensors are indispensable tools in both scientific research and industrial application. The ability to provide precise, reliable, and non-contact measurement make them invaluable in a wide range of fields, from automotive safety and healthcare diagnostics to industrial automation and robotics. As we look to the future, ongoing advancement and innovation in ultrasonic sensor technology promise to expand their capability and application even further, driving progress across various industries.